When it asks us to find a partial sum, that means when you add up the first n terms. Maybe you're going to add up the first 5 numbers in the list, or add up the first 6 numbers, or maybe the first 10 numbers, whatever it might be. If I look at number 4 here, we want to find the first 4 partial sums and the nth partial sum, so a rule for our sums. Our rule for finding any number in our list, a sub n, is equal to 2n minus 1. So if I plug a 1 in for my n, the first number in my list is 1. The second number in my list is 3. The third number in my list is 5. And the fourth number in my list is 7. If I want to find the sums, if I want to find the sum of the first number, well, it's just its first number, 1. If I want to find the sum of the first 2 numbers, I'm going to add my first 2 numbers together. 1 plus 3 is 4. If I want to find the sum of the first 3 numbers, I'm going to add 1 plus 3 plus 5, the first 3 numbers in my list, add up to 9. If I want to add up my first 4 numbers, then when I add them up, I get 16. If I want to come up with a rule for the sums, I've got a sum of 1, 4, 9, 16. These are all perfect square numbers. 1 squared, 2 squared, 3 squared, 4 squared. So the rule for my sum in this case would be n squared. We can also write our answers in what's called sigma notation. Sigma notation helps us find sums. We use this little Greek letter E, sigma. Underneath, it's going to tell you which term to start with. Do you want to start with the first number on my list, or maybe the fourth or the third? The number above your E is going to tell you which term you want to end with. So you're adding the first through 10th, maybe the first through 6th, maybe the 2nd through 5th. And then out in front is your rule, what you do to each number in your list. For number 5 here, we want to write the sum using sigma notation. So here's my first number, second number, third number, fourth number, plus dot, dot, dot. If I have my dot, 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 that means I'm going to infinity. I'm not ending here at the 4th term. So I'm going to start with an n of 1 and go to infinity. And I'm going to write my rule out in front. So each one of these is 1 over a perfect square, which would be 1 over n squared. For our last one here, for number 6, we want to find the sum of the 3rd through the 7th number, and our rule is k squared minus 1. Sometimes we use n, sometimes we use k, sometimes we use the letter I, it doesn't matter. So I'm going to plug a k of 3, 4, 5, 6, and 7 into my rule here, and then add those all up and get my sum.